a gap there. Let's see today again what is the chemical bonding part 3. So that day we have learned regarding the ionic bond being formed. Okay, so ionic bond can be formed between electropositive, that is a metal ion, and the electronegative, that is a non-metal ion. Then covalent, if you take, okay, covalent bond if you take, so both will be the non-metal or the electronegative atoms. Then further, coordinate covalent if you take, one will be the sharer and the other is the using those two electrons and forming the bond. Now today's class we move a little further in that. So what is that further is, we have, and that day we have seen what kind of atoms will give rise to ionic bond. We have taken sodium and chlorine as one such example, calcium and fluoride, magnesium and oxygen. These three examples we have taken that day. So let us see further now the properties of ionic bond. What are the properties? Once the molecule is being formed, then what are those properties? So properties of ionic bond. Properties of ionic bond. Let's see. The first property there, okay, the first property, so those are three-dimensional. Okay, the ionic bonds usually they are three-dimensional and usually they are solid in nature. Ionic bond compounds or the molecules, if you take, the arrangement of those atoms and ions shall be three-dimensional and it is going to be usually a solid. And in that there will be cation and anion. Cation and anion. Just one example I'll give. What is the meaning of three-dimensional? So sodium chloride, if you take, sodium chloride. So one crystal of sodium chloride, if you take, it will be containing several atoms of sodium and several atoms of chlorine. So how those are arranged? When you come to the second year, the 12th class, that time we'll be learning more about this. Now that is something like this. This is not there for which, just a little I am telling you. Okay. So this is a cube here. So where all sodium are present, where all chlorine are present. So sodium, if it is present here, okay. Next, this will be chlorine. Then again, this corner it is sodium ion. This is chlorine. Then you have here chlorine. This is sodium. This side it is chlorine. This is sodium. Like this alternately in one crystal, one unit cell we say. So they alternate. So you can observe there are 4 sodium ions and 4 chlorine or chloride ions are present. So cation, anion both are present and it's a three-dimensional thing and it's a solid. So that is the first property of the ionic bond. Then the second property, if you take, it is regarding electrical conductivity. The second property is regarding electrical conductivity. Okay. Now, in the solid form, if you take sodium chloride in the solid form, the electrical conductance is not there. But if you take it in the aqueous form, in the molten whatever form, so that time ions are present. And those ions, remember, sodium ions and chloride ions are there. Those are responsible for the conductance of that ionic substance. So electrical conductivity in the solid form, in the solid phase, it is non-conductor. But when it goes into the molten state or the ionic state, aqueous state, so there definitely it conducts electricity. Then further, the next point is regarding hardness. So they are quite hard. They are sufficiently hard. Okay. So you cannot break them so easily. You cannot separate the sodium and chloride or any such ionically bonded substance very easily by just by using some hand or something. So because they are very hard, at the same time, what you have is they have high melting point. They have high MP. MP is melting point. BP, when we write, that time it will be boiling point. Okay, so they have high melting point and boiling point. Then later, fourth point, solubility. If you check, solubility, if you check, solubility, they are soluble in polar solvents like water. Soluble in polar solvents like water. They are soluble in polar solvents like water, but they are insoluble in non-polar solvents like ether, benzene, toluene, and other. Means organics, whatever the solvents are there, in that it is not soluble. But these ionic substances, sodium chloride, potassium chloride, magnesium, most of the ionic, whatever bonded compounds are there, they are soluble in water because because water is a polar solvent. So ionic substances are soluble in polar solvents. They are not soluble in non-polar solvents. Okay, so not soluble. That also let me write it. Not soluble in polar solvents. Not soluble in non-polar solvents. Not soluble in non-polar solvents. Non-polar solvents is something. Ether is there. Ethers are there. Benzene is there. So in that all it is not soluble. Okay. Then final point regarding ionic bond. The final point is they do not exhibit isomerism. Okay, no isomerism there. What is isomerism is? What is isomerism is same molecular formula, different structural formula, different arrangement of the atomic groups what are present, and that will give rise to what? That will give rise to the isomers. So since there are no isomers usually in the case of ionic bond, so what shall happen is they are going to be non-directional. So these ionic bonds are going to be non-directional. So any positive ion is there. What is the meaning of this? Any positive ion is there. Say sodium ion is there or calcium ion. So whatever the chloride ion shall be there, let it be from any corner. Let it come from any corner, there shall be the attractive force. So it is non-directional. But when you go to the covalent, so it is going to be shared only between those two, whatever the sharing atoms are there. So covalent will be directional. But ionic bond, if you take, they are non-directional. So because there is no isomerism. So these are the 5 points there. These are the 5 points of the properties of ionic bond. Later, let's move further. So further is regarding writing of chemical formulae. Next is writing of chemical formulae. For this, what all you should be knowing? Okay, writing of the chemical formulae of the different molecules. So, what is that chemical formulae? Chemical formula is a symbolic representation of a molecule. All the time, writing sodium chloride, calcium carbonate, whole spelling if you write, and then in the reaction if you use those spellings, it becomes a very laborious work. So to condense that work there, to make short that work there, the symbolization of the whatever the atoms is there, it has been given. So first thing that you should be knowing there, okay, what is that writing of chemical formula is? It is a symbolic representation of the molecule. What it is it is symbolic representation. Okay, it is symbolic representation of a molecule. Example, okay, so if you take calcium carbonate, so the whole spelling if you write calcium carbonate, this will be sodium. So same thing, this calcium carbonate, it is mentioned as CaCO3. CaCO3 shall be calcium carbonate. Further, what is the next? For this, for writing of the symbolic representation, you need to know the symbols of different elements. You need to know the symbols of different elements. Okay, all the elements, their symbols you should be knowing. Like, say for example, sodium, it is Na. Potassium, Kx. Francium, Fr. Magnesium, Mg. Aluminium, Al. Manganese, Mn. So these symbols, these are all metals are written. You can also be writing chloride or chlorine, bromine, hydrogen. So these symbols you should be knowing. Okay. So for writing of the symbolic representation of the formula, you need to know the symbols of the atoms. Once you know the symbols, the next thing that you should be knowing is valency. Once you know the symbols, the next thing you should be knowing is valency. Valency is what is? Valency is combining capacity. With what number ratio of one element is going to combine with the what another ratio of the another element, or with whatever the other element is there. So what is the number of those elements which should be present in order to form the molecule? Say for example, so what is valency is? Combining capacity. Valency is combining capacity. Okay. Now, say for example, you take chlorine to be bonding with different metal atoms. So when it is bonding with the sodium, you have NaCl. NaCl. Okay. 1:1 is the ratio here. 1 sodium, 1 chlorine. Then when you take magnesium, so it shall be MgCl. 1 magnesium combines with 2 chlorines. Here why 1:2? Here why 1:1? Because sodium can donate only 1 electron and chlorine will receive that 1 electron. Sodium donates 1 electron, chlorine receives 1 electron. So between them there is a 1:1 combining ratio. When you come to magnesium chloride, magnesium donates 2 electrons. Magnesium has a tendency to donate 2 electrons, and chlorine, each chlorine will take up only 1. So in order to balance that, you require or you take 2 chlorines there. Then if you come to boron trichloride, BCl3, or even aluminium chloride, AlCl3. Boron trichloride, so 1 boron, 3 is the valency, so combining capacity is 3, so it requires 3 chlorines to be bonding. Then when you take the aluminium chloride, aluminium also, it has got 3 valence electrons, and to combine there and form the bond, AlCl3. So this is what is valency, that is combining capacity. It is the combining capacity. So once combining capacity is known, then we should be knowing there will be ions. Okay, usually for ionic bond what we have, there will be a cation, there will be an anion. A cation is one which is positively charged, which donates electron, and anion is another which is negatively charged. Say for example, okay, let's take cation, anion. Okay, few examples. Now sodium over this plus charge, magnesium over this plus 2. Then potassium plus calcium plus 2. Barium plus 2. Okay, aluminium plus 3. So here these are all what? These are all the cations which are positively charged. Which are positively charged as cation. Then anions are what? Chloride, Cl minus, Br minus. Okay. Then I minus. Then sulfate, SO4 minus 2. Then carbonate, CO3 minus 2. So wherever minus sign, whatever the molecules are there, the species are there, atoms or atomic groups are there, those will be the anions. So all this study, one is symbolic representation. For writing of the chemical formulae, you have to know what is the chemical formulae. It's a symbolic representation. For writing the symbolic representation, you should know the symbols for them. Okay, symbols there. So after knowing the symbols, you should be knowing the valency. That is the combining capacity. What ratio of elements combines with what other ratio of the other element. Then once you have that, then there is cation and anion. So cations will be positively charged, anions are negatively charged. So this is the basic requirement there. So once this is going to be ready, so there are some ions produced. These ions, they have got another word in the chemistry. What are these ions? All the ions called is, these are called as radicals. These are called as radicals. So what are radicals? Radicals are ions or group of atom with some electrical charge. Either maybe positive charge or negative charge. So such a species, ion is a group of atom or ion where it has got some electrical charge. It may be negative charge, it may be positive charge. So that's a radical. After knowing radical, the next thing that we have to move on to, so is rules for writing chemical formula. What are the rules for writing chemical formula? Let us go to that. And before that, let us little understand what are the different ions and what are their names like. Let's see. There are monovalent ions, divalent ions, trivalent ions. There are metallic ions, non-metallic ions. Okay, names and symbols of some of the ions. Let's see. Okay, names and symbols of ions. Names and symbols of ions. Learn it now only, okay? Now itself you learn it. Before this, you enter the 11th class. So these days are very handy, very easy. And for you, it is very easy to learn. You don't have a lot of pressure. So when pressure develops, again, these simple things to learn, it may become difficult. Okay, let's see. Name of the ion. Name of the ion and its symbol. Okay. So here we'll take first set is metal ions. Okay, metal ions. And fine. Sodium ion menacing.